Anyone know program computer? How to program computers? Wow, good. Anyone make electronics? Make electronics, yeah. You who don't know, you can come here and take course and learn to make electronics, I think. So it's great. Who have played with the ESP8266? All right, we have a few. I think you also can find them outside. It's a really exciting thing because it defines the IoT. And IoT is now so cheap. It's like $2 the chip, and it's a computer. It's similar to a computer, a home computer we had a few years ago. So it's $2. It used to cost $200, right? Now you can use IoT to toast your bread. So, not going to talk about toasting bread, but I'm going to talk about the ESP and Lisp. And because it's a Make conference, I made my own slide software. So it may not work perfectly. So we see what happens. My name is Jonas Karlsson, and I'm Swedish, but I live in Hong Kong 5 weeks at a time, because when I get bored and I go to another place which have a hackerspace and stay a while. So you might catch me in Shanghai, Beijing, Singapore, wherever. So we're going to talk about Lisp, and here's just a tiny introduction to ESP8266. They come in different formats, but here is a dual-core ESP8266. I used to have a quad-core, but when I sold 2 and I had to cut them off, now it's only two left, so it's a dual-core, I call it. You can only use one at a time, it has to have its independent power. But it's really a fun device to get started with and to play with. So what's interesting with this, it has about 40 kilobyte of RAM for your program, and it has 512 to 4 megabyte of flash. And some software give you a flash file system, so you can have files on it, you can read it, you can write it. So it's really kind of a really amazing device, I think. And the price point is totally right. So what I like with this one, and what is really inspiring when you get the one called NodeMCU, it has Lua on it. And Lua is an interactive programming language. Some people may know JavaScript. JavaScript is, you can go in console, you can type 3 plus 4, and it says 7, maybe, some of the time. So you can type something and something happens. And this is very close to how we used to use home computers, right? Nowadays, for most people, you have a computer on your desk, but if you want to program it, you don't know how to do it. You have to install a lot of programs. I think Chrome is trying to change it, so it become more like an environment for programming. But I also have a environment where I program inside the browser, and it's stored in the cloud. That's another thing I'm working for, called Panda language. We don't have time to talk about that, because that takes 3 hours. But Lua is interesting because you connect to this one as a terminal serial port, and you can type commands. You can write in functions and programs, and you can call functions. So you can say read pin 1, and it says, oh, it's 0 or it's 1, right? And so you can interact with it, and you can try out your program without recompiling and then flashing it, because that takes like a minute in a run time, right? And then you see, oh, it's not working, I need to change my program. So now you can just do it by connecting, right? But I try to use this one, and it has 20 kilobyte code free. But you load code in memory, it has less memory, maybe 10K free. And you create a function. Each function takes 600 bytes. And that's a lot. So you can't make a lot of abstractions. So Lua works fine if you have 1 page of code. That's it. And that's not much. Okay? So I want to make something more efficient where you can have more abstractions. So I work on a Lisp. I said, I haven't written a Lisp for a few years, so let's do it again. Okay? You should always do things again, because the next time you do it, you learn something new. Now, this is very special because Lisp, how many people know anything about Lisp? 1. Okay, I'm going to teach you Lisp today, so don't worry. Okay? You're going to be full Lisp programmers after 12 minutes. Okay? So, I'll teach you Lisp. All right? Very easy. This is a number. You type a number, you get the number. That's it. And this is a string. It's called hello world. This is possibly the shortest hello world in most languages you can use, right? Just type this with a quote, and it will print the same thing back. It's a program. This is a Lisp program. Okay? Symbols are just names of things, but they can also be X, and it can also be plus, or any letter combinations. And essentially anything which doesn't have a space in it is a symbol almost, as long as it keeps together, right? And symbols is what Lisp can do, and almost no other language can do. Okay? This is nil, is nothing. And we just write like parentheses. It looks like a very short list, and it is. It's an empty list. Okay? Then it has pair. And it's not a pair you can eat, because my pronunciation is funny. It's a pair of two things, right? And the dot signifies that you have one thing and another thing. And this is the only data structure which most Lisp come with. It's always have this. And it's the only thing you need, actually. Now, if we put 3 in a pair and nothing in the end, it's called a list. So it's not a pair. It's still a pair, but it ends with a nil. So this is the definition of a list. And we can combine it. And this looks complicated. But when we print it out and type it in, we type this. It's the same thing. It's just 3 pairs connected. The last element is empty. Okay? So, now we're going to call a function. We're going to add 3 and 4, because we know this gets 7. Often. Very often it gets 7. So, actually what we see here is a list, and it has 3 elements. First element is a symbol plus. Second element is a number 3 and number 4. So it's a list. This is data, but it's also a program. This is unique for Lisp. Okay? You want to call 2 functions, you put this together. And this is where people get afraid, because, wow, it's 2 parentheses in a row. I don't understand. Or I hate Lisp. But it's okay. It's okay. You can do that. Now, we're talking about hardware and doing things. So this one, I added 2 functions to my Lisp. One is called in, and one is called out. In takes a pin number you want to read the value of, and you can read it. And out takes a pin number and the value you want to write, 0 or 1. Okay? So that's very simple. And it's very easy to add these functions to my language. It's just 3-4 lines of C code. Okay? Now we're going to define a function which doubles a number. The number we give, we want to double n. And we have an n, so we say plus n. So this is how we define a function in Lisp. And it just doubles the number, right? And if we call it, we say double 7. And we hopefully not get 7, we get 14, right? Okay? It's still a list of 2 elements, all right? Now, if looks like this, also parentheses. If equal 3 and 3, because equal is a function. If is a function. So equal 3 will return true. And if it's true, it returns the green string. If it's not true, it returns the red string. But this could also be another program or data, so you have control. This is how you program in Lisp. This is the if statement, condition. Okay? How do you loop? This looks a little bit more complicated. And in the end, it's all the parentheses you hate, but you can give it to your grandfather because he's that old that he probably knows Lisp. So loop n. We will only loop n times. If n is less than 1, then we do nothing, nil. We return nil. If it's bigger, which is the else, we construct a pair of n and then loop of n minus 1. So if it's say loop 5, this will call loop again with loop 4, and loop 3, and loop 2, and loop 1, and loop 0, then it returns nothing. So if we call this one, what we get? We get 5, 4, 3, 2, 1. So Lisp has no loop construct necessarily. It's just call the function again. And if, all you need. Very simple. It's like a minimal virtual machine. Okay. This Lisp is interactive. So I try to make it fun to connect to it. And I'm going to show you that in a minute. But there's commands like trace on and memory. So you can debug it. You can say like, how much memory do I use when I run the plus 3 and 4? And we'll show you that, oh, it allocates the list and it gives up a list. It has a little bit built-in help. And you have some magical keys you can type while something is happening. So we're going to see that too. So let's do that. All right. Okay. I'm going to possibly put down this one. And what? Now it got funny. Sorry? Yeah, I will do it. Just need 2 hands for that. There we go. So there's a Lisp, and it usually says Lisp. And then, if it's basic, it says ready. And you can do 3 and 4. And somebody will tell me the result. 10. All right, we see. Sorry, 7. You have to do it again, all right? So this is a very simple Lisp, right? You can do things. So I can say help. And it says blah, 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 blah. And then it says symbols. These are all the functions it has. So it has about 100 functions in it already. So it's quite useful. Actually, these functions is enough for me to implement a basic interpreter. Somebody used basic when you were a little bit younger? Okay, so I wrote a basic, and I'm going to give a link to that, in Lisp. It's just a few hundred lines of code. It's very simple. So Lisp is very good to do symbolic manipulation and a program with symbols. So try to do that in C. Takes more lines. Okay. Now I'm going to run a function which takes long time. Well, somebody know what Fibonacci is? Fibonacci is the computer's nightmare function because it calls itself twice. So Fibonacci of three is 3. Fibonacci of 4 is 5. Actually 5 is 5. So it doesn't look like it does a lot of work, but let's do trace on. We do Fibonacci of 3. It's like what? You see, it calls itself a number of times here, right? And if you do Fibonacci of 7, it's like yeah, okay, it's finished. Huh? But when you just increase the number by 1, it does at least the double amount of work. So it's exponential complexity, it's called. And it will also use a stack because it grows. So it's really a test of the speed. So you can use this for benchmarking. Okay. We do trace off because now we do Fibonacci 30. And it's like, oh my God. Okay, it's doing something. My computer is doing something. I don't see it. My computer is hanged. What can I do? Oh, I've been waiting 1 hour. So this is a problem when you connect to a device or connect to this thing. You don't know if it's still working. So you put print statements, you program, it prints a dot. But you put it in the tightest loop, so it just prints dots and doesn't do anything. So it's like, oh, when you start modifying it, so it prints later. Okay? Well, it's still doing something. Or you think it's doing something? What? Check your fan, yeah. Actually, I run a Unix command before, it says disengage fan. But actually, this is running on the ESP. It has no fan. You can help me. Okay, so it's still maybe doing something. How many people think it's actually doing something now? I'm not sure. It hangs sometime, okay? I have a magical command. I press Ctrl-T now, and it shows the time since I start the ESP, and it shows the load. It's a supercomputer, it has a load. Okay, so 93%, 99%, it means it's busy doing something. And it's at 22 Fibo. 22 Fibo means that it has 22 functions of Fibo calling each other, waiting for results of the other one. And this keeps varying because it keeps doing things. Oh, where it's finished, and we got a number. Can you verify the number is correct? Okay, it looks good, he says. It's a big number, huh? So, it finished. But meanwhile, we could check, we could talk to it, right, and see that something happened. That's good, but it's not perfect. Let's do it again. And we're running and running and running. We say, oh, I give up. Take too long time. You press Control C. What is Control C? Break. Right. Break. It's going to break my computer? No? Okay. Break. And here, it shows me the stack. So it's a function called Fibonacci of 30, which calls a function called Fibonacci of 29, and it calls the Fibonacci of 28, which calls 27, calls 25, forever, right? And now, because I break it, I could make it go into debug mode, which I haven't implemented yet, and you can continue and you can change the values, maybe. Not yet, but it'll take a few days of hacking, right? And tomorrow, you help me, huh? Yes? So this is really exciting. The overhead of checking for the Control C and Control T is not even 1%. I do it every time I garbage collect. So if your program generate no garbage, you can't break it. But it's Lisp, so it's all garbage. Okay? It's all data, and when you don't want the data anymore, it's garbage. Okay? So this is cool. And observe here, like you type something and you can delete it. Ooh. Some of this command line program cannot do this. I had to write a function to do this. I had to interpret the Control H and the delete, backspace. But this is cool, but you have to type in a function every time you change it. So that's less cool. So we're going to play with the other core of my supercomputer. Okay? We connect to it. Is anything happening? I press Control L. What does Control L do? Clear the screen. Redraw the screen. So, anyone knows what Emacs is? How many people hate Emacs? How many people love Emacs? Nobody. You always use VI, right? I hate you. Okay. So, Lisp is cool. Emacs is cool. And VI is okay. But it has one function, and that is allows you to edit full screen. So you can walk down, you can go forward, you can insert text, and it shows you what you have in your file. This one is running on the ESP. So I was bored, and I had a lot of hackers around me in Hong Kong in the Maker Base. So I sat down and I wrote this function in like 3 hours. It's about 300 lines of code, implement a very simple full screen editor. You can page up, you can page down, and I'm going to add cursor keys at some point. It's like now the cursor key in the VT100 terminal do this, right? But the idea is if I combine this program with a Lisp, you can say, oh, this function, you can say edit and this function, and you get the screen of a function, because in the Lisp, a function is data. Because it's data, we can print it. Because it's data, you can edit it, and then you can save it again. So we can connect to this one, and we can edit it online, right? While connecting. So you don't need to install any software. Most computers come with a terminal program of some kind. So this is easy to play with and interact and call functions, right? Okay. Am I out of time, or how is the time here? Somebody else talking? I can go on forever. How many people will continue forever? All right. 1 minute. Okay. Any questions? Yes.
Kilobytes remaining. Oh, sorry. With the interactive Lua interpreter, there was 20 kilobytes remaining, but with this without the editor and this with the editor, what sort of resources does it take on the ESP?
So the editor is interesting because possibly you need to keep the text in memory. So that's the biggest cost. So the code does not take any place of the RAM at all. It's in Flash. The C code compiler is in Flash. So I can add 1 million functions, and the only thing which takes space is the symbol names, right? But for the Lisp, I'm working on a function where you define a function and it will automatically store it in Flash. And we'll be able to execute it from Flash. Because there's one area of the Flash memory you can write and read from as if it was RAM or a ROM. So you have about 20K available, but it's about 16K in the Lisp because I pre-allocate some memory in order to save memory. It sounds funny, but I've gone through many stages of optimizing it. For example, the symbols you see, any name up to 6 characters, just characters, does not take any memory space at all. It's stored inside the pointer. And so I do a lot of funny tricks. And numbers are not allocated on the heap either. They're stored inside the pointer. So certain bits in the pointer have certain meanings. So there's a lot of funny tricks you can find in the code. Okay, time out! Thank you.